Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 73 of physics. In today's lecture, we will discuss some consequences of convection. First of all, we will discuss formation of sea and land breezes. The two figures show how natural convection in the air causes a sea breeze in the daytime and a land breeze in the night time. In the day, the land gets heated up faster than the water in the sea. This causes the air above the heated surface of the land to warm up faster and therefore to rise. As a result, the relatively colder air above the surface of the sea moves towards the land to replace the hotter air. This movement of air from the sea to the land constitutes a sea breeze. Let us discuss that in detail. The radiation is coming from the sun in this particular case here. So, as a result, the land becomes hotter very quickly and the air above the land becomes less denser and it rises up. Now, to fill this vacuum of air created by the hot air, the cold air from the sea is coming to replace that vacuum. And this result in when it is going upside, so this is coming like this and that breeze is going again, it is coming, because we will discuss the next step in this second one, which is taking at night time. In daytime, we are only witnessing that the land becomes hotter quickly as compared to the sea water. When the land become hotter, then the air above that land becomes less denser and as a result it moves upward. Now, to replace this vacuum created by the hotter air, the water, the breeze from the sea is coming and that is replaced by the colder air. Now, at the night, what happened? At night, the land cools faster than the water in the sea. Therefore, the air above the surface of the sea is hotter than the air above the land. As a result, a reverse convection current is set up. As the warm air above the surface of the sea rises and the colder air from the land moves in to replace the warm air that set up a land breezes. The reverse process is actually taking place in this scenario. At night, the land is colder as compared to the sea water, which is hotter. Now, the air above the sea water becomes less denser, and as a result, it is moving upward like this. And to replace this vacuum created by the hotter air, a cold air from the land is coming to replace this air. and this process is totally the reverse of this process. So in this way, the formation of sea and land breezes uh, are taking place. The second consequence of this convection is convection current uh, in a room. So let us talk about that as well. Whenever a group of people enter a room, convection current are set up. The figure shows the convection current near a person. Ladies and gentlemen, when many people are entering the room, so it means that the room becomes hotter and the air near the person becomes less denser, and as a result it moves in upward direction. At the top, already colder air is compared to the hotter air near the person is coming down, that is a denser one, so it is coming down to replace that vacuum created by the person. Similarly, in both directions, this process can take place, and this is so the heat generated by the bodily processes such as breathing causes air near the body to be heated up by conduction. The warm air being less dense rises while the colder, denser air above the person sinks. This sets up a convection current. So, this was the second, and now we are coming towards the third consequences. The third one is convection current in ponds. Ladies and gentlemen, have you ever witnessed that in the cold winter the water above the surface of the ponds feels to be colder, while the at the bottom it is warmer? So God has created an environment for the fish is perfectly working correct. So let us discuss this convection. uh, During the onset of winter, the air above the surface of a pond is cooler than the water in the pond. The upper layers of water therefore lose heat to the air and become denser than the warmer water below them. The colder water sinks down while the warmer water below rises up. This sets up the convection current. So, in this way, you can see here the convection current is taking place due to the hot and the cold. Uh, in the winter, I am talking particularly. So, this uh, is for the marine life. Fortunately, for marine life, water has an anomalous behavior in that as its temperature falls to 4 degrees Celsius, its density reaches its maximum. A further fall in temperature from 4 degrees Celsius towards 0 degrees Celsius causes it to expand. This means that the convection current will stop when the water at the bottom of the pond reaches 4 degrees Celsius. The top layer of the water freezes to ice which floats and thus acts as an insulating layer to prevent further loss of heat from the warmer water below. Now, dear learners, we are turning our focus to some everyday applications of convection. That is also of extreme importance, in which number one is household hot water system. In the winter, we are using the boilers to get hot waters for bath and for different purposes. Let us discuss that actually what is going on in that system. First of all, let me discuss the working principle of the household hot water system, which is based on the convection in liquids, is I am showing it right now to you people. Ladies and gentlemen, this is the boiler, and there is a burner here you can witness. When the water in the boiler the water in the burner becomes warmer, it's expand in this direction, and it is moving to the upper part of the hot water tank. This is hot water, is indicated by this arrow, and at the bottom there is a colder water which is coming from this Saturn. Now, when the warmer water is moving upward to replace this area, water from the Saturn is coming in this way to fulfill this area. Now, again the process is started, and the warmer water is going up and the colder water is coming down. So there is an overflow pipe here, you can see. That is in case if the hot water is becoming more hotter, so that it will come to the Saturn, to this area. Actually, this is not taking place, but in few cases the overflow pipe is attached to the uh, cylinder, just in case the temperature of the water becomes too high and causes a large expansion of the hot water. Now, one thing more you have to observe here, ladies and gentlemen, that in physics we are saying that water maintain its level, as you can see it from this line. Now, this hot water tap must be attached below the Saturn. So the difference between the pressures will cause the water to flow through the hot water tap. In case if it is above the level of water of Saturn, then we will never be able to get any sort of hot water. So this is a very important application of the convection, which we are witnessing in winters in our household because for bath and for other things we are getting all these things. The next one is the electric kettle. Now, electric kettle is also another application of convection. Actually, what is happening? There is a heating coil of an electric kettle, and that is always placed at the bottom of kettle is shown heating coil which is placed at the bottom. When the power is switched on, the water near the heating coil gets uh, heated up and it expands and becomes less dense. The heated water therefore rises while the cooler region in the upper part of the body of water descends to replace the heated water. So here the hot water is rising and the cold water which is denser is coming down, and a convection current is taking place and hotness is distributed evenly to the all parts of the liquid, in this case water. So that was another application of convection which we saw in the form of kettles, electric kettles. The next one is air conditioners. Yes, air conditioners are also using the convection phenomena. The rotary fan inside an air conditioner forces cool, dry air out into the room. The cool air becomes denser, sinks, while the warm air below, being less dense, rises and is drawn into the air conditioner, where it is cooled. In this way, the air is recirculated and the temperature of the air falls to the value present on the thermostat. If the value of the thermostat is 16, it means that the convection current will take place until the temperature of the room reaches 16 degree, and you can observe that air condition is always installed at the top of the wall, because when we are getting cold air from the air condition, that is being denser as compared to the warmer air below the room. So that denser air is falling down, and to replace that uh, vacuum created by the uh, colder air, the hotter air is going up, and again the process is taking place and the air become colder, and in this way the convection current is taking place. So air conditioners are also another very important usage of the convection. The last one is refrigerators. Now every household is having the refrigerator. We talked about the refrigerator in the previous chapter in greater detail, but I told you that the consequences of these and the usage application of these will be given a touch very soon. So today it is the turn of those consequences as well as usage of those phenomenon which we studied. Now refrigerators work in very much the same way as air conditioners. The freezing unit is placed at the top to cool the air so that the cold air, being denser, sinks while the warm air at the bottom rises. This sets up convection current inside the cabinet, which help to cool the contents inside. Now you can see that this is the freezing unit. The air inside that is much cooler as compared to the downward cabinet, the one which we are observing at the bottom. So denser air is coming down and the warmer air which is less denser is going upward, and in this way the convection is taking place. Ladies and gentlemen, with this we came to the end of this convection. In the next topic, in the next lecture, we will discuss some consequences and usage of radiation. So stay tuned and don't miss the next lecture. Thank you very much for your time.